Okay, what we're going to look at today is lesson 6-7, which is similar figures. There's some things that we have to learn about similar figures, some terminology that will help this lesson. Okay, similar figures are the same shape, okay, but they're not necessarily the same size. That's really important, but the shape is going to be the same. Now, that might sound easy. Okay, so the shape's the same, but the size is not necessarily the same. What happens is they also will flip them and turn them a little bit. So there are some things that we got to look for, and I'll point that out as we go in this lesson. Okay, similar figures have corresponding parts. Okay, corresponding parts mean they're the same part on the other figure. Okay, and sometimes that's tricky to find, even though they're the same shape. You know, they're not the same size, and it can be flipped and turned a little bit. So sometimes it's challenging to find the corresponding parts, and I'll talk about that more as we go here. These are angles and sides in the same position is what they are. That's what corresponding parts are. So the corresponding angles are going to be the angles that are in the same position on each figure. Okay, and then corresponding sides are going to be the sides that are in the same position on each figure. Sounds easy, but it's not, because sometimes they're flipped or turned and twisted. Other times they're just side by side or set up the same, and then it's fairly easy to find them. But that's the challenge of this lesson. Okay, with that being said, let's take a look at what students are going to have to be able to do with this lesson. Okay, here now are two similar figures. Okay, I drew them the best I can, they're not perfect. Okay, now these, obviously they're not the same size, they're triangles. Now if we just take a look at the angles for a minute, and I point out a few things. If you notice, there are arcs in the angles. Okay, those represent corresponding angles. Okay, so A corresponds with D, one arc. B corresponds with E, two arcs in the corner, and C corresponds with F. All right, now with that being said, you can also find the corresponding sides now. Now the corresponding sides are what they're called, they're proportional. Okay, they're not going to be the same length, obviously, because the triangles aren't the same size, but the sides are proportional. Okay, so if we take this side here, which is 24, okay, it goes from 3 arcs to 2 arcs. Okay, that's proportional to this side right here. That's 6. All right, because it goes from 3 arcs to 2 arcs, and that's how you can find the corresponding sides and the corresponding angles. For the angles, look for the arcs, and for the sides, look at the between the arcs for the sides and match it up with the other figure. So this side corresponds with this side. Okay, this with this, I talked about that. So F and D correspond with C, A. Okay, now if you notice on this problem, we got to solve this. Okay, what we want to do is take something off of the smaller triangle. Okay, that we know that also corresponds with something on the larger triangle that's given. Okay, so it's useless to use CA because CA isn't given, nor is FD, so those aren't going to help us. But here we have where CB, which goes from 3 arcs to 2 arcs, is 6. That corresponds with this side right here. Okay, so the ratio we can use then is 6 over 24. Now this is off the smaller, this is off the larger. Okay, I'm just going to abbreviate just so that we point that out. So we're going to make an equal proportion here. Okay, now I need to solve for x. And x is on the smaller one. Here's x. So I put x right here. I keep small across from small. Okay, corresponds with 8.5. See, here's where AB is. 1 arc to 2 arcs. It corresponds with 8.5 off of the larger one. So I can put 8.5 right here. Okay, so now I have I've created a proportion, and I have 3 of the 4. So if I have 3 of the 4, I can cross multiply, which we've already learned, to solve this. So you'll take a calculator, go 8.5 times 6, okay, and divide that by 24, okay. And in that situation there, let me grab a calculator to double check, but I think it comes out to 2.125. Okay, so I go 8.5 times 6 divided by 24, and I do get 2.125. Okay, so that's what x equals. So this amount right here would be that, and it does make sense. Okay, obviously it's you know, you need to get a smaller answer than you get here because this is a little larger one. So you do want to make sure your answer is reasonable as well. Okay, let's look at one more. Okay, here is another one. All right, now this is one where it's flipped. Okay, this is a little more challenging problem. Okay, now if we look at the angles and look at a few things. Here's a right angle symbol. So G and M, they those would be corresponding angles. Okay, 3 arcs here, 3 arcs here. So those angles are equal. Okay, 2 arcs here, 2 arcs here. So those angles would be the same. 1 arc, 1 arc. Those angles would be the same. Now that will help us to find what we got to do on this problem. Okay, we have to solve for x, which is right up here. Okay, now what I want to do is I got to find something off of each of them that's given in their corresponding sides. So I look on this one here. Well, it doesn't matter which one I look at. But if I go from 3 to 1, okay, I go over here 3 to 1. That's what I have to find. Okay. So at 12, I could set it up like this. I could say, all right, well, on the large one where it's 12, okay, on the small one, if I'm setting up my proportion, on the small one, that's what I have to solve for, x. Okay, so I got to find something off of this now. This was large here. Okay, well, really the size on these two hardly matter. Okay, so let's find something that corresponds from this one. So it goes from 2. Okay, right here from 2 arcs to the right angle symbol, 2 arcs to the right angle symbol. So on this one, okay, I'm using the 12 and the 8 here, okay, corresponds with the 6, so I'll keep it right across from one another. Okay, so this is another way of setting this up. Okay, so now if I cross multiply, I have 6 times 12, okay, which is 72, okay, 8 times x, which is 8x. So if you divide, in this case here now, by 8, you're going to get x equals 9. Okay, so that means that x up here would be 9, and that makes sense because where it's 8 here, it's 6 here. Okay, so if it's 12 here, it's got to be less than 12, and 9 seems to be a reasonable amount. Now there's other ways to set these up. Okay. You know, as long as you set them up proportionally, you know, you're going to be okay. You know, another way to set this up is to take something off of this one, okay, that corresponds with this. Okay, 8 corresponds with 6. These we already determined were corresponding sides. 8's off of, let's say, the larger one, because it is a little larger. It's hard to see that, but judging from the numbers, it is a larger one. Okay, so now I can set up a proportion here where I'm taking, okay, large, I'll keep large across from large, so where 12 is, okay, that corresponds with x on the smaller one. So I kept large across from large, small across from small. Now we got our numbers set up a little bit differently, but we're going to get our answer the same. So 6 times 12, okay, in this case here, okay, once again, 72, okay, x times 8. Is 8x. Alright, so now if we divide both sides by 8 to isolate our variable, we get that x equals 9. Okay, so 2 different ways to set up the problem and to get the answer. Both are effective ways. This way might be a little bit easier to start with, keeping large across from large, small across from small. It might be a little more less likely to make mistakes setting it up that way. But they're using proportions to solve for missing side links on similar figures. I hope this helps. This is from lesson 6-7.